Today, we're going to talk about a concept that might just change, well, everything we think we know about technology. We're talking about the self-evolving machine.
But first, let's start with a question. We've got AI that can create incredible art, supercomputers that can simulate entire galaxies. But for all that power, there's a hidden limit. In a way, they're all kind of stuck. Why is that?
Well, it all comes down to something called the static design limit. You can think of it as this invisible wall that has boxed in every single machine we have ever built.
I mean, think about a jet engine or even your smartphone. Yeah, you can tweak them, make them more efficient, but you can't fundamentally change what they are. Their ultimate potential is set in stone the second they leave the drawing board.
And look, this isn't just some design choice we're making. It's actually baked into the laws of physics. Thermodynamics puts a hard, non-negotiable ceiling on how good a traditional machine can ever get. But biological systems, like our own brains, they play by a different set of rules. They evolve, they adapt, they literally rewire themselves. And that's the whole ballgame.
So if we ever want to break through that invisible wall, we can't just keep building slightly better versions of what we already have. No, we have to completely rethink what it even means for a machine to be better in the first place.
For literally centuries, efficiency has meant one thing: getting the most bang for your buck out of a fixed system. It's like trying to get the best possible gas mileage from an engine whose design you absolutely cannot change. That's traditional efficiency.
But adaptive efficiency? Now this is a whole different beast. It's not about how well the machine is doing its job right now. Instead, it's a measure of how fast the machine can learn and improve itself to tackle new problems down the road. It's basically measuring the machine's rate of self-improvement.
So let's just put these two side by side, because the difference is huge. On one hand, you got the old way, static, optimizing something that's fixed, and ultimately limited by physics. And on the other, you have this new goal, dynamic, where the system improves itself, aiming for growth that is, for all intents and purposes, wide open.
Okay, so how on earth does a machine actually do that? How does it get a mind that can evolve? Well, the key is this really fascinating idea called the Darwin-Gödel paradigm. So, the original idea, way back, was something called a Gödel machine. It was a theoretical AI that could rewrite its own programming, but only if it could first come up with a formal mathematical proof that the change would be an improvement. Super smart idea, but completely impractical. So that's where the Darwin-Gödel machine, or DGM, comes in. It takes that core idea and makes it work in the real world. Instead of needing mathematical proof, it just tries stuff out. It tests its own new code against benchmarks to see what actually works. It's a lot more like natural evolution. And the DGM just runs in this constant loop, over and over and over. Step 1, it changes its own code. Step 2, it tests that new version to see if it's any better. And step 3, and this is really clever, it keeps a whole library of all the successful versions. This allows it to explore tons of different evolutionary paths all at the same time.
And get this is not science fiction. There's a real biomedical research system out there called DREAM. And using these exact principles, it hit a research efficiency that was more than 10,000 times greater than human scientists. That just shows you the insane power of a system that learns how to learn.
But an evolving mind is only half the picture, right? For a machine to truly evolve, it needs more than just smart code. It needs an evolving body, too. The intelligence has to be able to reshape its own physical form to take on new challenges.
And that's where this amazing tech called Modular Self-Reconfiguring Robotics, or MSRR, comes into play. Just picture a robot that isn't one solid thing, but is made of thousands of tiny, identical little modules. Basically, smart Legos. These little guys can disconnect and reconnect into any shape the AI needs, letting the machine build the perfect body for whatever job it's doing.
And to keep this evolution going for the long haul, the machine has got to be tough. By building it out of self-healing materials, it could actually repair damage to itself all on its own, making sure it can survive and keep growing for a long, long time.
So this is where it all clicks. You've got this integrated loop. The mind, the evolving code, figures out a better way to do something. And then it tells the body, those modular robots, to reconfigure into a new, better physical shape to do it. The mind and the body evolve together. That right there is the complete self-evolving machine.
Now, a machine that can improve itself without any limits? I mean, the promise is unbelievable. It could solve some of humanity's biggest, gnarliest problems. But
and you knew there was a but. It also comes with enormous risk. It forces us to walk this incredibly delicate ethical tightrope.
And the number one risk, the big one, is what's known as the AI alignment problem. It's simple, really. If a machine is getting smarter and smarter in an exponential rate, how do you make absolutely sure that its goals stay aligned with our goals? Because an uncontrolled evolution, even one that starts with the best intentions, could spiral into consequences we can't even begin to predict.
So to handle that risk, there are a few safety measures that are pretty much non-negotiable. First up is sandboxing. You have to keep the AI in a secure digital environment where it can't cause any unintended harm. Second, you need constant human oversight, someone to keep an eye on it and make sure its goals aren't drifting. And finally, you absolutely need a kill switch, a big red button that provides a final line of defense to shut the whole thing down if something goes wrong.
And all of this leads us to the final, and maybe the most important question of all. Look, the technology for this stuff is coming. The promise is an age of intelligence that could solve diseases, climate change, you name it. The peril is creating something that we can no longer control. So the great challenge of our era might just be this. If we build a machine that can evolve, can we make sure that it evolves with us and not away from us?